Welcome to Course 4, Foundation, Certified Supply Chain Professional, CSCP, course, by SPAO Academy. Topic 1, Supply Chains, Demand Management, and Forecasting. Section 5, Forecast Accuracy and Measurement, Lesson 3, Measuring Forecast Accuracy. Measuring Forecast Accuracy. Objective. By the end of this lesson, you will be able to calculate and interpret common metrics used to measure forecast accuracy, specifically forecast error, MAD, MSE, and MAPE. Introduction. Why measure accuracy? In the previous lesson, we learned that no forecast is perfect. But if we know forecasts will be wrong, how do we know if they are usefully wrong or dangerously wrong? The answer lies in measuring their accuracy. Measuring forecast accuracy is crucial for several reasons. Monitoring performance. It helps us track how well our forecasting model is performing over time. Comparing models. It allows us to test different forecasting methods against historical data to see which one would have been most accurate. Making adjustments. If accuracy drops, it signals that we need to investigate why, e.g., a new competitor, a change in the market, and potentially adjust our forecasting model or parameters. Building trust. Quantifying accuracy helps manage expectations. Operations, finance, and sales teams can understand the typical range of error and plan accordingly. Think of a forecast like aiming an arrow at a target. Measuring accuracy tells you how close your arrows are landing to the bullseye. Key metrics for forecast accuracy. To measure accuracy, we need to compare our forecast to what actually happened. We call this the actual demand. Let's define the following. AT. The actual demand for period T. FT. The forecast for period T. For our examples, we will use this simple dataset of actual sales and forecasts for a 5-week period. Week 1. Actual sales, 100. Forecast, 110. Week 2. Actual sales, 120. Forecast, 115. Week 3. Actual sales, 110. Forecast, 120. Week 4. Actual sales, 130. Forecast, 125. Week 5. Actual sales, 140. Forecast, 135. 1. Forecast error, ET. This is the most basic building block of accuracy measurement. It is simply the difference between the actual demand and the forecast for a single period. Formula. ET equals AT minus FT. A positive error means our forecast was too low, actual demand was higher than we predicted. This is also known as under-forecasting. A negative error means our forecast was too high, actual demand was lower than we predicted. This is also known as over-forecasting. Calculations for our data. Week 1 E1 equals 100 minus 110 equals minus 10. Week 2 E2 equals 120 minus 115 equals 5. Week 3 E3 equals 110 minus 120 equals minus 10. Week 4 E4 equals 130 minus 125 equals 5. Week 4 E5 equals 140 minus 135 equals 5. While simple, the error by itself can be misleading. If we added up all these errors, minus 10 plus 5 plus minus 10 plus 5 plus 5 equals minus 5, the positive and negative values would cancel each other out, making it seem like our forecast was almost perfect, when in reality, we were off every single week. This is why we need other measures. 2. Mean Absolute Deviation, MAD. MAD measures the average magnitude of the errors. It tells us, on average, how much our forecast missed the actual value by, regardless of whether it was over or under. To do this, we take the absolute value of each error. Formula. MAD equals N area summation AT, FT, N. Where N is the number of periods. Calculations for our data. Find the absolute error for each week. Ignore the plus or minus sign. Week 1 to minus 10 equals 10. Week 2 to 5 equals 5. Week 3 to minus 10 equals 10. Week 4 to 5 equals 5. Week 5 to 5 equals 5. Sum the absolute errors. 10 plus 5 plus 10 plus 5 plus 5 equals 35. Divide by the number of periods, N equals 5. MAD equals 35 divided by 5 equals 7. Interpretation. For this 5-week period, our forecasts were off by an average of 7 units, e.g., 7 products, $7. A lower MAD indicates a more accurate forecast. 3. Mean squared error, MSE. MSE is another way to measure the average magnitude of the error. Instead of using absolute values, it squares each error before averaging them. This has an important effect: it penalizes large errors much more heavily than small ones. Formula: MSE equals NN area summation, AT, FT, 2. Calculations for our data. Square each error. Week 1. -10, ones 2 equals 100. Week 2. 5, ones 2 equals 25. Week 3. -10, ones 2 equals 100. Week 4. 5, ones 2 equals 25. Week 5. 5, ones 2 equals 25. Sum the squared errors. 100 plus 25 plus 100 plus 25 plus 25 equals 275. Divide by the number of periods, n equals 5, MSE equals 275 fifths equals 55. Interpretation. The result, 55, is not in the original units sold, because we squared the errors. It is a relative measure of accuracy. When comparing forecasting models, the one with the lower MSE is preferred, especially if large errors are particularly costly or disruptive to your operations. 4. Mean absolute percent error, MAPE. MAD tells us the average error in units, but what if you're forecasting two different products? A MAD of 10 units for a product that sells 1,000 units a week is excellent, but a MAD of 10 units for a product that sells 20 units a week is terrible. MAPE solves this by expressing the error as a percentage of the actual demand. Formula: MAPE equals NN area summation, AT, FT, AT times 100. Calculations for our data. Calculate the absolute percent error for each week, AT, FT, AT times 100, N. Week 1. -10 100ths times 100 equals 0.1 times 100 equals 10%. Week 2. 5 120ths times 100 equals 0.0417 times 100 equals 4.17%. Week 3. -10 110ths times 100 equals 0.0909 times 100 equals 9.09%. Week 4. 5 130ths times 100 equals 0.0385 times 100 equals 3.85%. Week 5. 5 140ths times 100 equals 0.0357 times 100 equals 3.57%. Sum the absolute percent errors. 10 plus 4.17 plus 9.09 plus 3.85 plus 3.57 equals 30.68%. Divide by the number of periods, n equals 5, MAPE equals 30.68% divided by 5 equals 6.14%. Interpretation. On average, our forecast was off by 6.14%. This is an intuitive and widely used metric because it allows for easy comparison across different products or business units, regardless of their sales volume. Lesson summary. Measuring forecast accuracy is essential for managing a supply chain effectively. We cannot improve what we do not measure. Here is a quick recap of the metrics we covered. Metric. ET. Name. Forecast error. Formula. AT. FT. What it measures. The bias, over or under, for a single period. Best use case. Identifying if a forecast is consistently too high or too low. Metric. MAD. Name. Mean absolute deviation. Formula sum. What it measures. AT. FT. Best use case. Average error in the original units, e.g., dollars, units. Understanding the typical size of the error in a way that's easy to relate to. Metric. MSE. Name. Mean squared error. Formula. N area summation, AT minus FT, 2, N. What it measures. Average error, but heavily penalizes large errors. Best use case. When large errors are much more costly or problematic than small ones. Metric. MAPE. Name. Mean absolute percent error. Formula sum. What it measures. AT. FT. AT. Best use case. Average error as a percentage of actual demand. Comparing forecast accuracy across different items or time periods. By using these tools, a supply chain manager can move from simply creating forecasts to actively managing and improving the forecasting process. I really appreciate you spending your time with me today. If you want to learn more, don't forget to hit that subscribe button. Your like means the world to us and helps this channel grow so we can continue bringing you great content. Thanks again, and see you on the next video.